हरि करना।
Let's begin the action. So we will begin with the classical statistical inference pipeline. This is very important. First we'll see this and then we will move on to the important topics under the inference, statistical inference or inferential statistics. Design of experiments is a cornerstone of the practice of statistics with applications in virtually all areas of research. The goal is to design an experiment in order to confirm or reject a hypothesis. So, this is a very important terminology. We will not say proving an hypothesis because we are never proving an hypothesis because it's always uncertainty is there, always some certain amount of uncertainty is there. So that's the reason we say that we either we confirm or reject a hypothesis, confirm or reject a hypothesis. So data scientists basically the overall goal is to design an experiment, is to initially I'm just giving you the four steps in a shortest way. So once you have a more clarity on the classical statistical inference pipeline and within the four steps, then we will move on to the nine steps procedure. So the goal, once you formulate your hypothesis, then we'll go on to the design experiment. The goal is to design an experiment in order to confirm or reject an hypothesis. So data scientists often need to conduct continual experiments, particularly regarding user interface and product marketing. So this basically this course reviews a traditional experimental design and discusses some common challenges in data science. It also covers some oft-cited concepts in statistical inference and explains their meaning and relevance to data science. Whenever you see references to a statistical significance, t-tests or p-values, it's typically in the context of classical statistical inference pipeline. So this process starts with a hypothesis. So for example, in this case, let's take an hypothesis of a drug A is better than existing standard drug, or price A is more profitable than existing price B. So with this kind of hypothesis, our experiments, our classical statistical inference pipeline starts, either drug A is better than the existing standard drug, or price A is more profitable than the existing price B. So an experiment, and after that we have to move on to the experiment. So an experiment, it might be an A/B test. So what is A/B test? We will be looking into that in next slide. So an A/B test is designed to test the hypothesis. So designed in such a way that it hopefully will deliver the conclusive results. Then once that's then the data is collected and analyzed, and then a conclusion is drawn. So the term inference reflects the intention to apply the experiment results which involve a limited set of data to a larger process or population. So again, I'm repeating the term inference. The term inference reflects the intention to apply the experiment results which involve a limited set of data to a larger population. So now let's deep dive into the statistical inference pipeline, and we'll see each and every sub step of it. So the classical statistical inference pipeline is a well established framework for making conclusions or decisions based on data. It typically consists of the following steps. Obviously, it starts with formulating a research question or hypothesis. So here this step involves identifying the research question of interest and formulating a hypothesis that can be tested using the data. So what will we do is we'll take an example. Parallelly, we will look into the each and every step in the classical statistical inference pipeline, and then we will also work on the example with the respective step. So which example I'm going to take is which one would be better? I'll take a scientific no scientific physics example. That would be much easier because most of the people might have studied that, so it would be very easy to connect with it. So I will take example of applying the classical statistical inference pipeline to a research question which is related to Newton's law of motion. That would be better. Okay, so okay, I'll take no I'll apply classical statistical inference pipeline to a research question related to Newton's law of motion. Okay, so it's not there won't be much difference between new scientific research and then our data science. There will be slight difference, so but still you should be able to connect with it. So okay, so research question first. Let's have a research question here. So research question is, does the force applied to an object affect its acceleration or not? That's where the Newton's second law of motion starts. So the research question for Newton is, does the force applied to an object affect its acceleration or not? That's what is research question. So now, as usual, we have discussed the step 1 is to formulate a research question, or hypothesis. Anyway, our research question was formulated, so now it's time for the hypothesis. So the research question of interest is whether there is a relationship between the force applied to an object and its acceleration. That's what is our research question. Does the force applied to an object affect its acceleration? So now the hypothesis. Now let's convert this research question into hypothesis. So the hypothesis for us is can be tested as so follows, like the force applied to an object is directly proportional to its acceleration. So that's what is the force applied to an object is directly proportional to its acceleration. So this is what is our hypothesis. This is what is our null hypothesis. That's what I'm saying is, as per my observation, I found that the force applied to any object is directly proportional to its acceleration. If you have higher force and then your acceleration is also high, if your force applied is lower, then acceleration will also be lower. That's what is my null hypothesis. I am not sure whether it is right or wrong. I observed one or twice, but I haven't done lakhs of experiments. I observed one or twice, so that's the reason. So that's my hypothesis. That's my null hypothesis. It's not alternate. It's my null hypothesis. Okay. Now, so that's what formulate a research question or hypothesis. Now the second step, design a study. So a study. Design a study, so we have to the study design involves specifying the sampling method. So obviously designing a study involves first one, which with which sampling method you want to go with, and then you have to decide a data collection process, and you have to decide the variables of interest and what levels of measurement you want to use, these things. Now let's see what we can do with our Newton's example. So step 2, design a study. Design a study. So a study is designed to collect data on the relationship between the force and the acceleration. So what's that? The simple experiment can be designed. Here there is nothing much complex. So here a simple experiment. Here we will be going with the experiments. A simple experiment can be designed where an object of known mass is attached to a string and pulled with varying amounts of force. Now the acceleration of the object is measured using a motion sensor. This is what is our second step. So the experiment to to they have designed, Newton has designed a study just to collect the data on the relationship between the force applied and the acceleration. So the simple experiment he has designed, that is where an object of known mass is attached to a string and pulled with varying amounts of force. The acceleration of the object is measured using a motion sensor. Done designing a study. The next step is collecting data. Data is collected by measuring the force applied, in this case, in this example. But if you see, what we do here is data should be collected from the population of interest using the specified sampling method and then data collection process. Because anyway, we have designed a specified we have designed sampling method and then collection process and variables of interest, and from the population you have to collect a specific you have to collect the data using a specified sampling method and then take the data collection. Okay, so now in this case it's pretty simple. So whatever the experiment you have done, step 3, collect data. So whatever experiment you have done, data is collected by measuring the force applied to the object and the resulting acceleration. So that's what the data collection here. So that's a step 3. Then let's get into the step 4. So let's explore the data now. Step 4 is to explore the data. So you can see here. So once collected the data, the collected data is explored to identify patterns, trends, and outliers, and other important characteristics that may influence the analysis. That's what we are going to do even with the Newton's example. That's what even Newton did. So step 4 is to explore the data. Explore the data. So the collected data is explored to identify any patterns or trends or outliers that may affect the analysis. So in this case, the data, so in what Newton did is the data is plotted on a graph to look for a linear relationship between the force and acceleration. That's it. This is very important step for Newton. Okay, next, let's get back. So next step is choose a statistical model. So once you explored your data, now it's time to choose a statistical model. A statistical model is chosen based on the research question and the characteristics of the data. So in this case, what Newton did, obviously it's pretty straightforward. It's we are looking for the force applied to an object is directly proportional to its acceleration. Not much of parameters or variables are involved here, and it's pretty straightforward. It's directly proportional. Obviously, it would be a linear relationship. Let's step 5. What Newton did, he has to choose a statistical model. So a linear regression model can be chosen to model the slope and the intercept are estimated. Okay, so that's what the statistical model is chosen. The parameters basically has used the linear regression model, so that the linear regression model can be chosen to model the relationship between the force. Let me write down. Obviously, when you use a linear regression model, slope and intercept comes into the picture. So basically, a linear regression model can be chosen to model the relationship between force and relationship between the force and acceleration. That's it. That's our step 5. Now let's get back to the step 6. So step 6 here it is estimate the model parameters. So now the parameters of the chosen statistical model are estimated using the collected data. That's what is step 6. And now here the step 6 again, the estimate the model parameters. As usual, we have chosen the parameters of the linear regression model. That's what here we are going to estimate. Here Newton has done, such as the slope. So what all the parameters of linear regression? Nothing much. Slope and intercept that we have discussed before also. Intercept are estimated using the collected data. That's it. Slope and intercept has to be estimated. Then let's get back to the next step. It's step 7. Now it's testing the hypothesis. The hypothesis formulated in step 1, that should be tested using the estimated model parameters and the data. So let's do it for the Newton's second law. So step 7 is test the hypothesis. So the hypothesis is that the force applied to an object is directly proportional to its acceleration and can be tested by checking if the estimated slope of the linear regression. Let's see if the estimated slope of the linear regression model is significantly different from 0 or not. Then once you test the hypothesis, now you have to draw the conclusions. Based on the result of the hypothesis test. Conclusions are drawn about the research question or hypothesis. So let's see what conclusions Newton had drawn after the hypothesis testing. So step 8 is to draw conclusions. Okay, so based on the results of the hypothesis test, conclusions can be drawn about the relationship between the force and acceleration. In this case, the hypothesis test indicates that hypothesis test indicates that the estimated slope is significantly 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 different from 0. So it can be concluded that there is a significant, so it can be concluded that there is a significant linear relationship between the force and acceleration. That's it. That's how Newton had come to a conclusion. So not yet done. So Newton has come to a conclusion, but he has to do something else. So that he has done, the final step is to communicate results. So the final step involves communicating the results of the analysis to others, often in the form of a research paper or report. This is very, very important step. That's how the other people got to know. That's how it's been widespread. That's how many other people got to use the fruits of that. So what Newton did now after drawing the conclusions, we'll see now. So step 8. So now step 9. So communicate results. Communicate results. So the final step involves communicating the results of the analysis to others. So the findings of the study can be summarized in a research paper. Very important, research paper or a report which can be shared with others in scientific community. That's it. So this is what is our the classical statistical inference pipeline.